Good evening, everybody. It is once again Ted the Speed Learner, and tonight I'm going to discuss the topic of hexadecimal. What is a hexadecimal? Well, I'm going to tell you about that in just a second, but first, I'm probably one of the rare few YouTube personalities on the YouTube platform that will never go, "Oh, please, 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 please like my video. And if you would be ever so kind as to subscribe to my channel, which will cause all my videos to be shared all over the platform." Let me tell you something. That ain't going to work. And I'll tell you why. Because YouTube cannot determine what they need to determine, which is whether my videos are keeping you guys on their platform by the use of the like buttons and the subscribe buttons, okay? Now, why do these people tell you this? Well, number one, it extends the watch time on their videos, which I'll tell you a little later why that would have an effect. But anyway, the other thing is that the like button itself, you could flip through things all day long, just go like. It's not going to tell YouTube anything, okay? Now, as for the subscribe button, that's a little different story. Have you noticed that when you hit the subscribe button now, this little menu pops up and it sets your bell notifications? There you go. That's why they're telling you that. Now, the bell notifications might tell YouTube something about how popular your channel is, and they might want to share your videos because of it. Okay? But what will cause YouTube to share your videos? Well, there are two things you can... Well, first of all, if people like you who are watching these videos right now were to copy the URL of the video and share it on a different social media platform like Facebook, what used to be Twitter, now is X, Gab, you got Truth Social, Instagram, Threads, whatever you want to share it on, that would get your video shared more, okay? Number two, when you increase the watch time of the video, then YouTube gets an indication that people are actually watching the whole thing and not just watching bits or pieces and jump cutting through everything in your video. So that is a good indication. The other thing you could do, okay, is you can leave very nice comments in the comments section below. And what that tells them is you were engaged, you watched, you replied, you really liked the content that you were watching, and that helps your ratings as well. So really what you really want to do if you want to increase, if you want to motivate YouTube to share your videos more often, watch the videos all the way through. Well, not you, but I mean your audience needs to watch the videos all the way through, increasing the watch time of every single one of your videos, or have them leave nice comments in the comment section below so that YouTube can see for themselves that, gee, this is a video we want to share all over the platform. And there you go. And another thing I need to mention real quick before we resume our video is that I have published 5 Kindle books. They're $5 a piece. If you want a copy of any of these Kindle books, just leave me a comment in the comment section below and I'll send you a hyperlink to my latest book, which you now can see on the screen. And then from there you can find my other 4 Kindle books, and there will be more Kindle books coming soon. It's all up to you. Buy them and let me know what you think about them. Alright, on to the video. Good evening, everybody. It is once again Ted the Speed Learner, and tonight I'm going to discuss the topic of hexadecimal. What is a hexadecimal? Well, I'm going to tell you about that in just a second, but first, alright, I guess the first thing we need to do is spell the word hexadecimal. There you go. There's the word hexadecimal. Alright. This whole thing would be a mystery unless you knew the following information. The Greek prefix hexa means 6. That's this part right here. It means 6. Now, if this hexa, or this prefix hex, is Greek. Okay, but here's the thing. This has a prefix, says deci on it, but it's also known as deca, which is 10 in Latin. Okay, so anytime you see deca or deci, you know that that represents 10. I'll show you that right here. Okay, now these two words, which is a prefix, yet another prefix, and another root word, they've been joined together. So if these words are joined together, then that means that 6 plus 10 equals 16. Does that start to clarify everything for you? Alright, now, when was the last time you looked at a numeric keypad? Well, I just happen to have one right here on my scientific calculator. There's your numeric keypad. There's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There you go. The numbers 0 through 9 are the 10 part of the decimal. Okay? Because if you're counting in deca or deci, you're counting in groups of 10, which is represented by 0 through 9. Okay? Instead of counting like you count on your fingers, you go 1, 2, 3, 4, 5, so on and so forth. You would start with 0. 0, 1, 2, 3, 4, and then your other hand would be 5, 6, 7, 8, and 9. Okay? Now, what about the last part? Well, since we already know that 0 through 9 is most of this, we have to have a representation for the numbers 10, 11, 12, 13, 14, and 15. We have to have representation for this, and we can't represent it with digits. So what did they do? Well, they came up with letters. A, B, C, D, E, and F. That kind of looks like, have you ever looked at musical notation where you have songs that are in the key of A, B, C, etc., etc.? Kind of the same concept, but not really. I mean, that's a good way to remember it, though. Okay? So anyway, many mathematical computer applications use hexadecimal, but our focus will be on the changing binary into hexadecimal. But before I cover that, I want to give you a brief history of hexadecimal. The history of the hexadecimal system is a little sketchy. The first major reference can be found in a book that was published just prior to the United States Civil War. What's the title of this book? Well, it's called Project of a New System of Arithmetic. And I provide you a web address down here in the description box below where you can click and you can see this book and read it for yourself. But this code wasn't widely used until the computer language known as the formula translator, which we now know today as the Fortran, okay? Because Fortran is actually an acronym based off the formula translator, okay? So you have Fortran, and it's an acronym for Formula Translator. Okay? Now, there are different versions of Fortran, and the first time that the hexadecimal system was used was in Fortran 4. Okay? Now, if you want to further research the history of the hexadecimal, feel free to do so, because you might find it harder than you think to find the answer. Alright, now, here's the key. Do you recall and I'm going to cover this further in yet another video I'm going to do right after this one, which is going to be based off of something called Unicode. Do you guys recall in my video about the American Standard Code of Information Interchange, where I had that, okay, and I said that that represented the capital letter A. Okay, now you say, okay, how does that binary number, which you know as a binary digit, or well, in this case it'd be a byte, which is 8. These are bits. This is a bit, this is a bit, this is a bit, so on and so forth. And this whole string of 8 bits is a byte. Remember all that? Okay. Now I also taught you in the American Standard Code of Information Interchange that all of these are placed in columns. And I said that this is 1, this is 2, this is 4, this is 8, this is 16, 32, 64, and 128. Okay? So this is the 1 column, this is the 2, this is the 4, this is the 8, all the way up to 128. Okay? Now then, if there is a 1 bit in this column, you have a 1 right here. If there is a 1 bit in this column, you have a 64. Well, what's 64 plus 1? Well, that's 65. And the 65th character of the American Standard Code of Information Interchange, which is this one right here, happens to be the capital letter A. That's what it is. Here's the problem, though. We're going to be venturing out of something called the Unicode. Alright? Now, so you have the 1 column, you have the 2 column, you have the 4 column, you have the 8 column. Now these 4 binary digits here are these 4 right here. You're going to actually split this 8-bit thing here, this whole byte. You're going to split this whole byte in half. That's right. So you're going to have, and we're going to erase all this. So basically what you're going to have is this half of the byte is going to be down here, and this half of the byte will be in its own thing, okay? So what you have here is you have a 1 bit in the 4 column, and there of course there's no 1 bits in any of the other columns. So what you have is a 4. Now, what about this set of 4 here? Well, you have a 1 bit in the 1 column. So, the 65th character in the American Standard Code of Information Interchange is also the 41st character in hexadecimal, which we're going to go into in my video about Unicode. Okay, and I'm going to talk about this again when I talk about that particular topic. So I want you to stay tuned, because it's very important you understand this information, because once you understand this, you can read Unicode. Alright? So, bear with me. I want you to stay tuned. I want you to watch the Unicode video right after you watch this one. Alright. I will tell you more in a future video, so I'd like for you to stay tuned.